Hi everyone, you're welcome to Learn Maths with me. In this channel, I'll be taking you through in-depth tutorials covering a wide range of topics from basic arithmetic to advanced maths. If you're new on this channel, I would want you to please like, share, and subscribe. And to my returning subscribers, I'd like to say a very big thank you to you all. Now let's go into what we have for today. Today we'll be taking a look at how to convert our decimals back to fractions. How do we convert our decimals back to fractions? If we have 0.75, for example, so what we do is we write it as 0.75 over 1. Now, anything we divide by 1 does not alter the value of the number. So in order to get rid of the decimal, because there are 2 digits after this decimal point, we multiply by 100. That is 1 and 2 zeros. So we multiply the 0.75 by 100. And then, because we are multiplying the numerator by 100, we also multiply the denominator by 100. So by the time we solve this, 0.75 multiplied by 100, we are left with just 75. And then 1 multiplied by 100, we are left with 100. So 0.75 can also be written as 75 over 100. But we can also still simplify 75 over 100, because 75 is equals to 5 multiplied by 5 multiplied by 3, and 100 is equals to 5 multiplied by 5 multiplied by 4. So we cross out the factors that are common on both the numerator and the denominator. We can see that we have 5 in the numerator and 5 in the denominator twice, so we cross out the 2. So 0.75 written as a fraction is equals to 3 over 4. Let's take a look at another example, 0.3. So like I said earlier on, you just simply write it as 0.3 over 1. To get rid of the decimal point, because there's only 1 digit after the decimal point, we multiply by 10. That is 1 and 1 0. So of course, whatever we multiply by the numerator, we also multiply by the denominator to balance it up. So 0.3 times 10 gives me 3, and then 1 times 10 gives me 10. So 0.3 written as a fraction is 3 over 10. Easy. Now let's look at a third example. Now this is a mixture of a whole number and a decimal, but it's still the same thing. We solve for the part of the decimal. 1.05 is the same thing as 1 plus 0.05. So 0.05, we rewrite it as 0.05 over 1. So to get rid of this decimal, we multiply. What do we multiply by? We have 2 digits after the decimal point. So we multiply by 1 and 2 zeros. That's by 100. We multiply the numerator by 100, and we also multiply the denominator by 100. So that gives me 5. 0.05 times 100 is 5, and 1 times 100 is 100. So it gives me 5 over 100. 1 plus 5 over 100 is 1 over 20. Now let's take a look at 0.625. 0.625, we still do it the same way. We write it as 0.0625. So we write it as 0.0625 divided by 1. Now, how many digits do we have after the decimal point in this case? We have 3 and 4. So we multiply it by 10,000. That is 1 and 4 zeros. So we multiply the numerator by 10,000, and we also multiply the denominator by 10,000. By the time we multiply it by 10,000, each of the zeros that we are multiplying it by pushes the decimal point to the right. So we'll be getting rid of the decimal point, and then we'll just be having this as 625. 625, and then 1 multiplied by 10,000 is 10,000. So we can rewrite it as 625 divided by 10,000. 625 is 25 multiplied by 25, and 10,000 is 25 multiplied by 25 multiplied by 16. So we've been able to write it as a fraction. Now let's take a look at how we convert a recurring decimal to fraction. This is a recurring decimal. We have 0.555555. We want to convert it to fraction. Now this is going to be slightly different. we're going to write our 0.5555 as an equation. So 0.5555, let us represent it with the value x. 0.555 by x. Now, I want to get a second equation. So I multiply this by 10. I multiply this side by 10 and I multiply this side by 10. So this gives me 5.5555 is equals to 10x. So what do? I simply subtract my first equation from my second equation. Don't get confused, don't worry. If I subtract first equation from second equation, all I am left with is 5. And then if I subtract x from 10x, this x is the same thing as 1x. So it's like 10 minus 1. So what I have on this side of the equation is 9x. So my 5 is equals to 9x. Now I want to know what the value of x is. So I'll divide both sides of the equation by 9. Because I don't want 9x. All I want is x. All I'm solving for is x. So my 5 over 9 is equal to x. So 0.5555 is equals to 5 over 9. This is how we solve for recurring decimals. Now we're going to take another example, but it's going to be slightly different. It's also a recurring decimal, but it's going to be slightly different. Now, in this example, we have 0.060606. The reason why I said it's slightly different is because it's not the same number. We have 2 digits. We have 0 and we have 6, but it's also a recurring decimal. So what do? Like I did in the first example, I'm going to write it as an equation. So 0.060606, I'll represent it with x is equals to x. Now, because I have two numbers, the 0 and the 6, I'll multiply it by 100 because I want to multiply it. I want to push my decimal point to the first set of the recurring decimal, of the recurring digits. I want my decimal point to come after the first set of the recurring digits. So if I multiply this by 100, I'll have 6.060606. So that will be 100x. If I multiply it by 100, I'm pushing this decimal 2 places. So that gives me 6.060606. That's 100x. Now I subtract my first equation from my second equation. So if I subtract this from this, all I have is 6. And then if I subtract x from 100, I have 99x. So I want to solve for x. So I'll divide both sides of my equation by 99. So my x is now 6 over 99. Now 6 over 99, I can bring out 3. I can divide both the numerator and the denominator by 3. So my x can also be rewritten as 2 over 33. Now we have some questions for you to try. Feel free to pause the video. The answers will be in the next slide. Thank you for watching. I'll see you in the next video.